Okay, so you've made it this far, you've checked components, you've checked your soldering, your unit is still not powering up. Another diagnostic we can do is to check the power with a multimeter. So you will need a handheld multimeter for this. And there are two ways we can check. One is when it's disconnected from power, we can check the resistance. So the power rails, on most modern things, there are two power rails, a plus and a minus in our case, and in any 500 series module, you'll have plus 16 and minus 16, and then ground. So we include test points for those things. So you can just go ahead, set your meter to read resistance. If your meter has multiple resistance settings, that's this ohm symbol here, let's set it to 20K for right now if you have a 20K setting. Okay, so black probe goes on ground. Red probe, I'm going to put on plus 16 for right now. And what we see here is just an arbitrarily high number, 0.888 mega ohms. You know, that's a lot of resistance. And that's really what we're looking for here. The exact number doesn't matter at all. It could be a good bit lower than that. We want to be in the thousands, in the Ks, or the high hundreds at least. But what we're really looking for here is that it's not zero. If I were to just touch these probes together, I get zero, basically 0.1 ohms. That is what a short looks like, and that's what we're really looking for here. This is really just a short test. So I go ground, let's check the negative rail. Okay, and I've got it moves around, but 1.3 mega ohms. It's totally fine if your number moves around a lot. As long as it's not settling at close to zero, you don't have a short. So I'm going to go ahead and connect this to power. These LEDs come on. I don't know if you can see that, but on our 500 series modules, if we have room, we like to put these LEDs for a quick visual check of the power rails. If they are lit up, everything is working well, or at least they are getting power just fine. Okay, so now we can check actual DC voltage. So I'm going to set the meter to this V with the two lines above it. One of them's dotted. I'm going to check the same spots. Plus 16 volts, 16.17 volts. Great. Minus 16, minus 16.28. Okay, so that's what we're looking for. Power rails do not need to be precise for audio electronics like this. So as long as you're in the range of what you're expecting, that's totally fine. So this checks out. Now let's look at one that does not check out. What I've done here is intentionally introduced a short in the power rails between V minus and ground. So I had to take out this discrete op amp, and I just put a jumper between those two pins. And this is obviously not a mistake you would make, but it represents a very common mistake, which is that there is a short somewhere in between one of the rails and ground. And I just want to show you what this looks like. So let's do our resistance test again first. So 16 volts to ground plus 16 looks fine, 3.4 million mega ohms, that's totally fine. Now let's check, oh, okay, so there's our short, 0.8 ohms. So that's not exactly zero, but that is what a short would look like if you had one on the board. Let's see what it would look like if we turned on the power. And look at that, that LED is not lighting up. And that is because this fuse here, these little things are not capacitors, though they look like them. They are self-resetting fuses. Basically, if too much current goes through them, they get really hot and they block any current. So I can barely touch that one. This one is fine. And let's see what happens if we check DC volts. 16.8, so positive rail, doing fine. Negative rail, 0 volts. So that applies to more than just this 500 series module. Most power supplies these days will have some sort of built-in circuitry protection. Ours is built into the 500 series module here, but if it weren't, it would have tripped the overcurrent protection in the power supply. So often if something is booting up for a second and then going dark, or just not booting up at all, it could be a short in the power rails, in one of the power rails that is tripping the automatic protection. So I'm gonna take this off of power. And what I would recommend in this case, obviously we know where the issue is here. It's that jumper. But if you didn't know where it was, it's very often that one of the integrated circuits has gone bad, either by exposure to electric shock or because maybe you had one in backwards or in the wrong position and you powered it up. So those can often cause these kind of power supply issues. So what I recommend for the next step, if you've got some sort of short, take out all the integrated circuits. I'm going to take out my intentional short here, obviously, and then check again. And we should be looking fine here. Now, one pro tip for you, our boards all have these nice test points here, but those, you can't always fit those. Not every brand puts those. So if you're troubleshooting something that doesn't have those pads, you can take out the ICs and use the IC pins. So I happen to know that these ICs are dual op amps, and that the power pins on a dual op amp are 4 and 8. But you should confirm this. You should Google the name of the chip that you removed and pin out, and then you will find a data sheet that shows you where the power pins are. ICs are numbered like this: 1, 2, 3, 4, 5, 6, 7, 8. They go counterclockwise. So pin 4, minus 16.3 volts. Pin 8, 16.3 volts. So exactly the same as if we had probed our test points instead. So that's just a trick you can use if you don't have test points like this.